So welcome you all for this unconventional machining process course. The course code is ME8073 and this is a professional elective 2 for the mechanical engineering students, regulation 2017. And in this video session, we'll be studying about the advanced nano finishing process, unit 4, in which we'll be studying about the introduction to advanced nano finishing process. So the objective of studying this unconventional machining process is to learn about various unconventional machining processes and the various process parameters and their influence on performance and their applications. So in unit 4, that is advanced nano finishing process, the students will be studying about abrasive flow machining, chemomechanical polishing, magnetic abrasive finishing, magnetorheological finishing, magnetorheological abrasive flow finishing, and their working principles, the equipments, and the effect of process parameters and applications, advantages, and limitations of advanced nano finishing processes. So these are all the textbooks and references books for this unconventional machining process course. And the course outcomes. So upon completion of this course, the students will be able to explain the need for unconventional machining processes and its classification on completion of unit 1. And the students will be able to compare various thermal energy and electrical energy based unconventional machining process from unit 2. And from unit 3, the students will be able to summarize various chemical and electrochemical energy-based unconventional machining processes. And from unit 4, the students will be able to explain various nano abrasives-based unconventional machining processes. And from unit 5, the students will be able to distinguish various recent trends-based unconventional machining processes. So introduction to advanced nano finishing process. So to make different products in various shapes and sizes, many times the traditional manufacturing techniques does not work. So one needs to use non-traditional or advanced manufacturing techniques in general and advanced machining processes particularly. So later includes both bulk material removal, advanced machining processes, as well as advanced fine finishing processes. So the advanced finishing processes are, the first one is abrasive flow machining processes, magnetorheological finishing, and magnetorheological abrasive flow finishing, and magnetic abrasive finishing, and chemomechanical finishing. So abrasive flow machining. So with today's focus on total automation and flexible manufacturing system, this abrasive flow machining process offers both automation and flexibility. And this was identified in the year 1960s, during 1960s, as a method to deburr, polish, and radius difficult to reach surfaces and edges by flowing abrasive laden polymer and to and fro into vertically opposed cylinders. So here it uses two vertically opposed cylinders which extrude an abrasive medium back and forth through a passage formed by the workpiece and tooling. So you can see from the figure here, you have an upper hydraulic cylinder and the lower hydraulic cylinder, and the workpiece is placed here, and abrasion occurs wherever the medium passes through the restrictive passages. So the key components of abrasive flow machine are the tooling, and the types of abrasives, medium composition, and the process settings. So principle of abrasive flow machining. So the medium is a mixture of a viscoelastic material and abrasive particles. It enters inside the workpiece. So here is a workpiece, and then through the tooling. So through the tooling, this abrasives and visco material mixture enters. So these abrasive particles penetrate the workpiece surface depending upon the extent of this radial force acting on this abrasive particles. So this you can see here the zoom view of this portion of the workpiece, and there we can see this abrasive grains and the surface surface roughness peel and this microchips. So due to this tangential force, the material is removed in the form of chips. So this is a schematic diagram of this abrasive flow machining. And coming to the application of abrasive flow machining, in aerospace industries, used to improve surface quality and enhance the high cycle fatigue strength, optimize the combustion and hydraulics, and to increase the airflow, and can be used to extend the component life. And in automotive industry, abrasive flow machines can be used to enhance uniformity and surface quality of the finished components, used to increase engine performance and to increase flow velocity and volume, and fuel economy is improved and the emission is reduced, and the workpiece life is extended by reducing wear and stress surfaces. And in medical industry, they used to eliminate the surface imperfections where dangerous contaminants can reside. It will be used to improve functionality, durability, and reliability of this medical component. So the advantages of abrasive flow machining processes are listed below. So it has an excellent process control, can finish both the internal diameter and the outer diameter of the component, and a good control of radius generation. It's fully automated system capabilities, and it's faster setup and quick change tooling. And the last advantages is faster changeover of media. Coming to the disadvantages, this fixture can be expensive. So the capital investment is also high. So with this, we come to an end to the introduction of this nano machining processes. So thank you and have a great day.